Nicolaus August Otto, the four-stroke engine. Controlled explosions inside an engine. That's the basis of our modern mobility. Four piston strokes that move the world. The four-stroke engine invented by Nicolaus Otto. Here's how things look inside a four-stroke engine. While moving down, the piston sucks a mixture of petrol and air into the cylinder and then compresses it as it moves back up. A spark ignites the explosive gas and drives the piston down again. This is the power cycle. The movement of the crankshaft drives the piston up again and the spent gases flow out through the exhaust valve. Let's look at that again. The intake valve opens and closes as the petrol is sucked in during the first stroke. Then the compression and the explosive combustion. As the piston goes down, the connecting rod drives the crankshaft. The principle is amazingly simple, but it needs a complicated mechanism to make it work. How many people know what really happens when they press down the accelerator? The accelerator pedal controls a valve. Petrol flows through it, shown here in slow motion. It mixes with moving air and is atomized. The camshaft opens the intake valve. The piston inside the cylinder compresses the mixture of petrol and air. The ignition. The engine produces its power when the piston is driven down again by the explosion. During the fourth stroke, the camshaft opens the exhaust valve and the exhaust flows into the exhaust manifold. A look inside the exhaust manifold. A special lens allows us to see the exhaust gases flowing through it. The engine runs more smoothly when it has four cylinders which go through the four-stroke cycle at different times. But it took a long time to develop the modern four-stroke engine. Motorized traffic began with the huge and clumsy steam locomotive. But getting it going was such a complicated business that the steam engine was practically useless for short runs. And the huge machines required an enormous amount of room. That was a considerable problem for industry, but still the number of steam engines in use increased rapidly. But they weren't without their dangers, as exploding boilers sometimes showed. Engineers tried to find new solutions. In Paris in 1860, the Belgian engineer Jean-Joseph Etienne Lenoir presented a gas motor. Instead of steam, it used lighting gas. As it was attached to the city gas supply, there was no need for a large boiler. That made it ideal for industrial use. Lenoir's most important innovation was to electrically ignite the mixture of air and gas inside the cylinder, though without compressing it. It was somebody else who came up with that idea. Nicolaus August Otto came from Holzhausen in the Taunus region of Germany. In Cologne, he had a job as a travelling salesman for groceries. Perhaps he started thinking about a new engine on one of his many trips. As early as 1861, Otto sought a patent for the use of liquid fuel in Lenoir engines. He wrote that the engine could be of considerable use in the movement of vehicles. But his alcohol carburettor didn't receive a patent. An expert who was consulted said it introduced nothing fundamentally new. In the same year, exhaustive experiments with the Lenoir engine led Otto to the four-stroke principle and to the idea of compressing the fuel. Otto wrote, "I was so certain of what I was doing that I threw caution to the winds, and instead of building a one-cylinder model engine, I immediately built a bigger four-cylinder engine." He regarded it as so promising that he gave up his job and dedicated himself completely to his invention. But for this idea, Otto didn't seek a patent. That later turned out to be a disastrous mistake. As he was short of money, Otto sought financial help from the engineer Eugen Langen. They founded Otto and Company and developed a conventional gas engine. It was ignited with an ignition system that projected into the cylinder. Otto's idea for this atmospheric engine was to allow the actual combustion to pass unused and then to use the piston returning in the cylinder as the working cycle. Eugen Langen contributed to the engine's success by introducing freewheeling. This innovation allowed the engine to run smoothly and quietly. At the 1867 World Exhibition in Paris, the engine was awarded a gold medal as the most economic source of power for small workshops. Otto and Langen founded a gas engine factory in Deutz near Cologne, which quickly became a flourishing concern. Production rose from 46 engines a year to over 200. Now Otto could return to his old idea for a four-stroke engine with fuel compression. His revolutionary idea was the compressor. By compressing the fuel before ignition, he achieved a greater explosive force and thus more power. The first working four-stroke engine had one cylinder and an output of 3 horsepower. Patent number 532, awarded to the inventor in 1876. A summer day in 1878. From his first four-stroke engine, Otto had developed a production model. He tops up the oil and checks all the details. Then he turns on the gas supply attached to the motor. The gas flows in. These bellows regulate the gas pressure. He turns on the flow of gas to the engine and ignites it. Now the oil supply is turned on. Otto gets the engine going using a large flywheel. Slowly, the piston starts to move. Gradually, the power of the engine turns the flywheel without human help. The camshaft, and on the left, the intake valve. The gas tap for regulating the gas supply. Farming was one of the first areas in which Otto's engine replaced the steam engine. Engines began to be used everywhere. And Otto's factory in Deutz was the centre of this development. The factory produced engines in all shapes and sizes. The largest weighed a colossal 8,000 kilograms, but its output was only 20 horsepower. The triumph of the four-stroke engine was overshadowed by problems over patents. As a result, Otto's patent was withdrawn. The inventor never recovered from this blow. He died embittered at the age of 70 in Cologne. Also responsible for the success of the factory in Deutz was the technical director, Gottlieb Daimler. Daimler and his chief designer, Wilhelm Maybach, were responsible for developing the production version based on Otto's prototype engine. They both left Deutz and developed a small, fast-running engine. In 1885, it demonstrated its practical efficiency in this motorized bicycle, a forerunner of the modern motorcycle. Daimler's contemporaries were astonished when they first laid eyes on his motorboat. At roughly the same time, Karl Benz invented another technical variation of the engine. Incidentally, his motorized carriage was the first patented car in the world. But the horizontal flywheel of his four-stroke engine ran more slowly and was heavier than the engine developed by Daimler and Maybach. At first, the loud, smelly automobiles were confined to the highest reaches of society, like Kaiser Wilhelm. But by the 1920s, the car had replaced the old horse-drawn cabs in the streets of the large cities, whether in Berlin or Paris. Cars were no longer a sensation, but just a part of everyday life. The engine Otto developed took the world by storm, in airplanes and airships as well. The demand for cars rose rapidly. In America, Henry Ford was the first to introduce a new approach to industry, the production line. Hundreds of thousands of these engines were assembled on the production lines and put into the Model T Ford. 15 million of them were produced, and the car had become a mass-market product. Although the outer form has changed radically over the years, Otto's four-stroke engine remains the driving force behind most cars. The basic principle underlying the engine is still known as the Otto cycle. The development of the engine continued. Automotive engineers produced 6, 8 and 12-cylinder versions of the four-stroke engine. Modern electronics now play an essential role. But the mobility the car gives us has its price. Apart from the noise, the exhaust fumes have helped to pollute our environment. New developments are necessary. A hydrogen-driven engine is in the experimental stage. It would be ideal for the environment. No harmful exhaust emissions, just steam. But it'll take a long time to develop a production model. Hydrogen can only be stored at very low temperatures or under great pressure. The design may have changed in the course of time, but what matters is what's inside, and that's simply a newer version of an invention that's more than 100 years old, Otto's four-stroke engine.
Kilometer,